All right. So, uh, this is how you find the pH of a strong acid. Pretend you didn't know that yet. You read the question, it says, what is the pH of a solution containing 0.234 molarity of HCl? So, it's totally based off of memorization. You got to memorize that's a strong acid. There's 6 of them. You got to know it. If you don't, it's going to be tough to do this in the middle of a test or assignment. So, here's what I know about strong acids. I know that we should focus on a chemical reaction in order to figure out the stoichiometry. That's what gives us the H3O plus. And once we're in H3O plus, we're in what I call the rectangle that lets you convert between those 4 bullet points or like corners to get down to pH. So, step number 1, what does HCl do in water? Well, HCl is a strong acid, which is code for strong electrolyte. So when you put it into H2O, it breaks up into H plus and Cl minus. That's balanced. So there's no need for any stoichiometric coefficients. Now, you also need to be confident that H plus is the exact same thing as H3O plus. If that's kind of iffy for you, you could also write out this chemical reaction as this, do the Bronsted-Lowry donation of protons, acceptance of protons. This proton gets bounced over here, produces the conjugate base of Cl minus and the conjugate acid of H3O plus. Either way, we have a 1-to-1 ratio. Okay, another assumption. We want the bracket of H3O plus. That is in molarity. So the problem proceeds just normally when we're given the molarity of HCl. If we're given grams and milliliters, you gotta do the background work to get it into molarity first. Okay, so we have that chemical reaction now, and we can say, oh, there's a 1-to-1 ratio of HCl to HCl plus. Therefore, whatever the concentration of HCl is also the concentration of HCl plus. So boom, we just thought of step number 2. The concentration of HCl will be equal to the concentration of H3O plus. Therefore, the concentration of H3O plus is, look at the problem, 0.234 molarity. All right. Once you get an acid, you sort of get introduced to the top left corner of this rectangle. And our job now, I'm going to zoom in so you can see that better, is to get down to pH. I imagine most of the time that formula is not given to you, so you may have to have that memorized, but pH is equal to the negative log of the concentration of H3O plus. So pH is equal to negative log of 0.234. And then you plug that into your calculators, putting negative log base 10. Sorry, negative, gotta find my calculator. L. I have a TI-89 where there isn't a button for it. Log base 10 of 0.234. And in my calculator, I get the final answer at 0.63 for my pH. Cool. Hope that helps.